Welcome back, everyone. We are going to continue our discussion on working with ExpressRoute by now talking about the implementation process of actually creating your live ExpressRoute circuit and connecting it to a virtual network. Be aware that most of the concepts we talk about in this lesson will be demonstrated in our hands-on demonstration in the next lesson. In this lesson, we will start with an overview of the big picture steps of the end-to-end ExpressRoute circuit implementation process. And then we will break those steps down by first focusing on creating an ExpressRoute virtual network gateway, creating the ExpressRoute circuit itself, both on the Azure side and the service provider side. Focusing on creating our circuit, we're going to have a really quick high-level side discussion on a feature called bidirectional forwarding detection, from which we will go through our next implementation step, which is creating our peering, and then moving on to our last step, which is connecting our ExpressRoute virtual network gateway, or in other words, our virtual network, to our newly created ExpressRoute circuit. So starting off with the big picture overview, there are really 4 big picture steps that we are going to focus on creating our circuit. Step 1 is to create our virtual network gateway, specifically an ExpressRoute virtual network gateway. Inside of our virtual network, we want to connect to ExpressRoute. From there, we will then go ahead and create our actual ExpressRoute circuit. Technically, you can swap the steps of creating your virtual network gateway and the circuit, but for our demonstration, we will start with the network gateway. As part of the circuit creation process, you will create it on the Azure side, from which you will then coordinate with your service provider, who will then provision the ExpressRoute circuit on their end as well. After our ExpressRoute circuit is created both within Azure and with our service provider, we then need to create our peering, which is essentially the BGP peering that connects our on-premises network to our Azure resources, of which our 2 main peering types is private, which is referring to an Azure virtual network, which is going to be our main focus, and we also have the option of creating a Microsoft Cloud peering, which peers our on-premises network with different Microsoft 365 services and also other Azure managed services as well. And then our last step will be essentially to put everything together, in which we are going to connect our ExpressRoute virtual network gateway to our ExpressRoute circuit, giving us a full end-to-end ExpressRoute connection. Let's expand on each of those steps in a little bit more detail, starting with creating an ExpressRoute virtual network gateway. Now, this step is going to be very, very familiar to a process of creating a VPN gateway within a virtual network. In fact, there really isn't that much difference, except for the fact that we are creating an ExpressRoute gateway instead. The only main differences really come down to SKUs, in which we need to set up our gateway, and we need to choose our SKUs, and we have our same gateway subnet and subnet delegation concerns that we talked about again in our previous VPN lessons. In our example off to the right, it is again a very similar setup process to our VPN setup, except for the main difference in that our SKUs are going to be a little bit different. In this case, our example is using an ultra performance SKU. After our network gateway is provisioning, we then want to move on to creating our ExpressRoute circuit. Now, creating our ExpressRoute circuit is really a 2-step process. We need to configure it within Microsoft Azure, and we also need to take some of that configuration information and bring it to our service provider so they can go ahead and set it up as well. On the Azure side of the process, we need to choose our billing and service models, of which you can see an example on the right side, in which we are choosing a service provider, in this case, choosing a peering location, bandwidth, circuit SKU, and billing model that we want to work with. And as we mentioned in our lesson on working with connectivity models, from here, we can choose to connect with a service provider, or we can set up a direct model connection as well. When working with a service provider model, once you create your Azure side circuit, this is going to create a string known as a service key, which can be most easily thought of as the pairing information that your service provider is going to use to provision a circuit and connect it to your Azure side ExpressRoute circuit configuration. Once you bring your service key to your service provider will then provision a connection on their end, and depending on your service provider, that turnaround time may vary. In our demonstration, we are going to be working with a provider that will provision their circuit within about a minute, which is a really nice automated setup. Some other service providers may take a little bit longer to turn it around as well, so definitely be aware of that. Next, I want to very, very quickly talk about a feature built into our ExpressRoute circuits that you need to be familiar with called bidirectional forwarding detection. Really, all you need to know about this feature is that it is a feature that is enabled by default in new ExpressRoute circuits, which greatly improve circuit failure detection speed and especially greatly improve your failover times from your primary connection over to your secondary connection. Now, from a configuration perspective on the ExpressRoute side, there actually really isn't anything you need to configure because it is enabled by default in any new ExpressRoute circuits. However, be aware that within your local or on-premises network configuration, you may need to enable this feature as well. Basically, how it works is that with our default setting of bidirectional forwarding detection enabled, the failover time in response from our primary connection to our secondary connection falls from minutes to less than a second, really greatly improved time. How it works in an example scenario here, if our primary connection between our partner edge and the Microsoft Edge goes down, with bidirectional forwarding detection enabled, it takes only less than a second to automatically fail over to our secondary connection, and we really don't experience any real interruption of service. With this feature not enabled, that failover time goes from less than a second to minutes, in which case, yeah, you'll probably realize your connection is down. Moving on to our next big picture step, we have that of creating our peering, which is going to be our example off to the right side. When working with peering with virtual networks, we are most concerned with our bottom right example called Azure Private Peering. However, be aware we also have the option of peering with Office 365 and other Azure services as well. Regardless of what option we go with, this peering is essentially the BGP peering between our on-premises network and Azure. In which case, we are establishing our BG peer from on-premises to Azure so we can go ahead and automatically discover and exchange routes. Within a single ExpressRoute circuit, you only create a single private peering, and this private peering, which is referred to as a private peering domain, can connect to multiple virtual networks at the same time. Moving on, our final step in the big picture process is to now, since we have everything created, let's put everything together. In which case, we are going to connect our ExpressRoute virtual network gateway to our newly created ExpressRoute circuit. Now, this is also going to be a little bit of review from our VPN sections, in which we go to our network gateway settings, create a new connection, and then from our connection menu, we'll go ahead and set our connection type to ExpressRoute, and then choose our pre-created ExpressRoute circuit that we are going to connect to. Again, not all that different from our VPN gateway connection process, and in which case, after our connection is complete and confirmed to work, we will then want to more likely monitor our connection to make sure the performance is as we expect it to be. With that, that's going to conclude our quick high-level overview of how to implement an ExpressRoute connection. Again, we are going to demonstrate these steps in practice in our hands-on demonstration in the next lesson. Let's go ahead and review our key takeaways before we move on. We talked about the big picture connectivity workflow for creating an end-to-end ExpressRoute circuit process, in which we need to create an ExpressRoute virtual network gateway in our given virtual network, create an ExpressRoute circuit on both the Azure side and the service provider side, create the BGP peering, whether it is a private type to our virtual network or also Microsoft 365, and we need to then link or connect our ExpressRoute network gateway to our ExpressRoute circuit to complete the process. We also very briefly talked about a concept known as bidirectional forwarding detection, which is a feature which is turned on by default, which enables rapid failover from a primary to a secondary ExpressRoute circuit. Like we said, it's turned on by default, so there really isn't anything to configure on the ExpressRoute side. However, you may need to configure your local network environment to take advantage of that feature as well. That's going to go ahead and wrap this lesson up. Let's move on to the next one.